Hi guys, in this video I'll go over the LinkedList class. I first explain the concept and then I'll go over an example. Let's start out with the concept. So a linked list works a little bit different than an array list. A linked list consists of nodes, and internally it has the first reference to the root node called root. That is the very first node or very first value stored in a linked list. And this is initially null. If we haven't added anything, it is null. Each node then stores an element and the reference to the next node. So let's say I were to add two values to this linked list. Let's say value 4 and 8. It would have 4 and then a reference to the next node, which stores 8. And then that one has a reference to nothing since we haven't added anything else. So it is a chain of references, and each reference holds a node, and that node holds a reference to the next node. Now let's see how this works along an example. So I can create an object of the linked list, calling the linked list class. Then I specify the elements I want to store in it, similar like an array list, and I call the constructor. I can also use the daemon operator here to infer the element type. I import this in the java.util package, and now I can add elements to it. Let's say I call add 5. This will internally create a new node that stores 5, and that node then references nothing. So here the size of this list is now 1 because I have one node in it. If I call add a second time, we'll start navigating these references, starting at the root node. So root goes to 1, and then the next one, this one is null. So here it creates a new node with 7, and the next one is null. Now if I add another one, add 4, it will again start at the root, navigate it until the end, and here that's the end, so it adds a new node here with 4, and this reference is null. Note that every time we call add, we have to start at the beginning. That's a little bit different with an array list where we can use an index to jump right to the end. And one thing that is similar to an array list here is that we can keep adding elements. There's no limit to it. We can keep elements as we need to. Now I can output this using the printline method. The class also overrides to string, so it will output it in a nice format. And here I currently store 5, 7, and 4. Now internally this is stored with references and nodes as I pictured up here. We can also use an index for int I equals 0, I less than list.size, I plus plus. And I output this with a bracket before, and then I use list.get, and I specify here the index I and close square brackets. And running this will output each element in a square bracket. Actually meant to use just print, not print line. So I run this one more time, and here outputs 5, 7, and 4. Now there's a small gotcha to this, or small gotcha to this, because this works just as fine as an array list, but it's not very performant. The reason for this is when we have list.size and we access something by index, each time here it starts at the root and then it counts the number of steps it takes. So initially when it's 0, it goes to 5. When I is 1, it does 2 steps. The first one, second one. If I is 2, it's 1, 2, 3 steps. So if we have a very large list, let's say 1,000, in each iteration I have to start at the beginning, count to the index that I want to get, and access the value. So it's really inefficient for that. For that, an array list is much, much more quicker because an array list has internally the array and it can access each element by calculating the offset. Now, another way of using the linked list is the for each loop. Let's say here I also want to count the total. I have total initially 0, and then I do total plus equal value. This does for every value in the list. I add it to the total, and then I output the total afterwards. Now running this, it will iterate over the for each loop, add up all the values, which is here 16. This one is much more performant because internally this will keep track of the current reference. So we'll hold a new reference to the first object, iterate to the next one, get the value, to the next one, get the value. In each iteration, it does not have to start at the very beginning. So for linked lists, always use the for each loop. We should really try to avoid an index-based loop. Similar, like the array list, we can call a remove method. We can here remove the very first element just by calling remove, or we can remove by index. So let's say index 1. If I then output the linked list again, and I run this, this will now remove the element at index 1. So here, what it'll do internally, it get rid of this node, and then 5 will now reference the next node after the one that we deleted. So it's 5 and 4. I can also remove the object. So here I also have to do integer value of, and let's say I want to remove 4. If I output this again, we can see it didn't use the index, but it used the value that it removed. So which one do you pick if you need random access? So any index, I want to get the element at index 23, it's better to use an array list. If it's just sequential storage, every time you start at the beginning and you iterate through, you can use a linked list. Linked lists also may use less memory. There's some overhead with the references, but that's really negligible. But for an array list, every time it doubles, so there's always more memory wasted the larger it gets. With a linked list, it just has the right number of nodes that are needed. I hope you enjoyed this video. Thank you for watching.